Okay. So then we present the effects to the user during the interactive auditing process, where they can resolve their safety and mark them with one of the three available annotations, safe, unsafe, or color checked. And after any of the effects have been audited, CargoScan produces a detailed audit log that is composable and contains all this information. So safe and unsafe can be used when we can determine the safety of an effect locally based on the surrounding context around its location. And color checked is to indicate that its safety depends on how it's being called. So let's assume that we have two effects, one in function bool and one in blah, and we start with blah, we audit it, and we mark it as safe. We're done here, everything's great, and we go to bool, and the effect there is color checked. So we mark it as color checked, and what CargoScan does is that it propagates it to up the call stack to all the call sites, and now we have two more auditing locations that we have to inspect. So until we can either resolve the safety of the effect or until it reaches the publicly exposed API, which is how we can further track this information across crates boundaries. CargoScan provides functionality so we can take all public functions of a crate that were marked as color checked and import them when we are auditing parent crates. So, and then treat them as effects, much like we do with system side effects. And in this case, that means that in crate A or B, whatever call to foo will be captured as effect. All this functionality and the way that we are modeling the effects in CargoScan allows us to automatically generate default audits, which is that CargoScan can mark conservatively every effect in a crate as color checked and then propagate them accordingly, and without the need of any manual inspection, and then just take the public color checked functions and import them in parent crates. And this is particularly useful when we have very large libraries where only a small subset of them is actually being used, so we don't want them to audit them in their entirety. We implemented CargoScan as a VS Code extension, so it's very easy for users to take advantage of all the interactive IDE features, and like checking types, definitions, navigating the source code, which makes the assessment during an audit much more easy. We present the effects that we identify as a list of distinct auditing tasks that the user can annotate in any order, and we highlight the effects and annotate them with the safety annotations in the source code. So if we go back to our example with unreachable unchecked, this is a color checked effect because it depends on buff and count, and if we mark it as such, then CargoScan presents a preview window with all the call sites that this effect is propagated to. We can see that the initial effect is marked as completed, and we can further track our progress and see that 2 new audit locations were added. So let's see now if this approach makes things easier. To evaluate CargoScan, first we want to answer how much code do we need to audit. Again, we use Hyper as one of our case studies, and we perform a full audit on it, and it's 29 transitive dependencies. And we find that with CargoScan, we can reduce the total amount of lines of code that we actually have to audit to a median of 13.2%. And with an average of 23.7 per package. So that means that most packages require very little auditing. And this is what we can see here in the full distribution, the number of total code that we have to audit and for how many packages, number of packages that this number corresponds to. And these results are also very consistent with our ecosystem analysis. Then we want to answer how often is code color checked. So in practice, we did have reasoning about the calling context was actually necessary when we audited hyper and the dependencies, and we, on average, we marked 14.5% of the effects as color checked, and we also, even though it was rare, had to reason about color checked effects across crates. So we had 2.1% of public functions marked as color checked. And even though this propagation introduces more audit locations, in reality it didn't introduce a lot of additional effort, because we only had to audit 2.4% per location with the original location included. Finally, we want to just see how if CargoScan flags real vulnerabilities. So we match existing audits from CargoVet to any package versions in RASEC, the central security database for Rust, and to find any packages that had associated bugs with them. And we found that during those audits there were 20 related bugs that were actually missed. 4 out of them were out of CargoScan scope, so we audited the rest of them, and we found that CargoScan flags effects related to 14 out of 16, which means either the bug location itself or code related to it, either that flows into or from the bug. And we also found that 9 out of them required to reason about the calling context. So does that mean, in this case, that auditors would have found these effects if they were auditing with CargoScan? Not necessarily, but it does mean that CargoScan can correctly include those buggy locations and identify them as effects during an audit, and it will guide auditors and users to audit those locations. And it further highlights that being able to express context sensitivity is actually really important. So CargoScan is actually used in action for real by a startup for about 6 months to audit any new crates in the ecosystem, which is very exciting. And to conclude my talk, I introduced CargoScan, a semi-automated auditing tool to make the auditing of Rust crates more effective. Thank you.
We have time for questions. So thanks for the talk. Did you get any feedback from the people at Cubist who are using it? Did they say, "Oh, this is great," or "We hate X," or "We wish you would do Y"?
The feedback is positive. They find it very efficient to use it. There are also, of course, there are a lot of features that we can add to the tool to make it even more interactive as a VS Code extension. Yeah.
And once you finish the audit, can you put your results back in a format so that like the CargoVet can consume it?
No, because it's not exactly comments. It has full details about all the effects, how they were annotated, their other metadata related to them. But currently we don't have human notes in our audits that CargoScan produces, but that can be a feature that we can also add.
Okay, thanks.
Hi, thank you for the talk. This seems like really interesting work. I would think that if a crate gets updated, you might need to re-audit it. Do you have any way where you can mark some sort of effects as, oh, this hasn't changed, so we don't need manual intervention again, or could you speak to that?
That's a great question. So currently, no, but it's future work to add functionality to just audit the delta and whatever code that affects within the crate instead of the entire crate again. But yeah, that's not currently something that we are supporting.
Thank you.
When you were showing the results, you said that you correctly identified 14 out of 16 locations where there were bugs.
Mm-hmm.
Surely if I'm auditing it, I want to check more locations than there are bugs than fewer locations than there are bugs, because otherwise I can't check for the bugs. Do you have any idea why you didn't catch those two cases and what you can do so then you get an overestimate instead of an underestimate?
So we didn't catch the 2 cases out of the 16 because currently we're not supporting macros and they were related with macro codes, but that's also future work. And was any other part of your question that I missed? Yeah.
Yeah, so we don't have time for more questions. Could we change the mic to the next speaker?